Here we go. We have a question, add 1 to a linked list number. So you have given a linked list where each element in the list is a node and have an integer data. You need to add 1 to the number formed by concatenating all the list node number together and return the head of the linked list. So the head of the linked list represent the first element of the given array. So you have given head as 4 and we want to add 1. So as we know, if we want to add a number, we add on the rightmost side. So if we add 6 with 1, the answer is 7. Here is the modified linked list. We have to return the head. Head is 4. On the second example, the answer, the test case is 1, 2, 3. If we add 1, it will become 1, 2, 4. If we look at the constraint, it is given the elements of a node can be between 0 to 10 raised to power 5. I assume this is wrong because a number range is 0 to 9. So I checked and run on a sample test case. So as I expected, here the constraint is wrong. It is 0 to 9. So that's about the problem description. Now it's time to build the approach. We have given head node this and we want to access the last node. We want to access the last node first because if we want to add a number, we add that number on the right hand side. So for this, we need to reverse this linked list. So after reversing, we have this and head points to this. So after reversing, we can easily add 1 here. So I will maintain a variable, its name is carry and a value is 1. We have this, so for iterating, we also need a current. So current points to this value. We have a value 6 and a carry 1. So the resultant must be modified linked list or modified node. So it is 7. If I take a mode with 10, because the number is in the range of 0 to 9, so I have to take a mode. So it is 7. We have modified it. And we will take some variable as carry. Why it is important? In this case, it is not important. We have modified list as this and we have carry as 0 because I have added a number and there is no carry further. So if we want to take a carry, we have to do it like this. Number or value divided by 10. In this case, it is 0. So if I add 0 here, it is same. So we have answer as this. I will talk about this in another test case. So we have answer as this. But as we know, we have first reverse the linked list. So we have to again reverse the linked list to get our head. So if I further reverse this linked list, we have this and this is our head. So we will return the head node. The answer is 457. In this case, it is correct. But let's take one edge case. 8 and 9 and 9. So if I reverse this, we have this and we want to add 1 here. So I can easily add 1. So the modified value is 10, but the 10 is not correct value. We have to find the value between the range of 0 to 9. So if we add a number here, as we know, it is 0 and we take 1 as carry. So same applies here. we have a value as 10, we take mode. So this is the original value or modified value. This is the modified value. So if I take 10 mod 10, the answer is 0. So the real value is 0 and value is 10. If I take divide 10, so 10 divide 10, the answer is 1. So this is our carry. So we take a carry here. 0 here, current points to this value. So we take this data and we added our carry. Now current points to next value. We want to add 1 here. So it is 0 and we take 1 as carry. Current points to next value. We want to add 1 here. The answer is 9. So it is 009. So we reverse this and the answer is 900. Because if we add 899, if we add one value to 899, the resultant is 900. So let's take another test case. This is a edge case 999 and we want to add 1. So first we need to reverse. So after reversing, we have this linked list. Current points to head value. This is our head after reversing the linked list. And we want to add a value here. So we will add a value. So it is 0. The modified value is 0 and we take 1 as carry. So we want to add 1 here. Current points to next node. It is 0 and we take 1 as carry. Current points to this value. So it is 0 and we take 1 as carry. 1 as carry. Now if we increment current, we lost access to the last node. If we update our current node, current pointer, then we lost access to our last node. So in this case, we will check, is this the last node? Yes, in this case, this is the last node. So we will just break out from the for loop and we will not increment our current node, because after that we want to add a value. So this is our resultant and after that we want to add 1. So current points to this value, current points to this value, this node, and we have this. If there is a still value present in the carry variable, so we will add 1 here, because we have maximum value as 9. So if we add 1 here, so the maximum carry we have is 1. So the value is 9 and we added 1, the answer is 10. If we reverse this, the answer is 10. So if there is a still carry present, we will add the carry. The carry maximum value is 1. So either you can add 1 or you can add carry. I am adding 1. So this is our answer and this is your head. Head points to this node. But this is not the real answer. We need to reverse this linked list. After reversing the linked list, we have this. We have this 999. So if we add 1, the answer is this. So let's talk about how to reverse a linked list. If you know how to reverse a linked list, then you can skip this part. I will tell you how to reverse a linked list. We have this this node. We have this linked list. So this is our head. I will tell you how you can reverse a linked list using recursion. So if you want to know how to reverse a linked list using iterative manner, so the link is provided in the description box. In this video, I will tell you how to reverse a linked list using recursion. So this is your head, and after reversing, this will be your new head. So after reversing the linked list, this will be your new head. So the last value will be your new head. So for recursion, there's a recursive stack. So first head points to this value. Now we call its next node. Now head points to this value. So we will call its next value. So it points to this value. So for this, it will call its next value. So this value. So we have this. We will check. Is this the last node? Last node means its next is null. Is the node next is null? In this case, yes. So it is our answer. So we will return, and we will return from here, and we have this as our current head. So after recursive calls, we have this, but its next is pointing to 1. Its next is pointing to 1, and after reversing the linked list, we have this as a resultant. Means 1 next points to 2, 2 next points to 3, 3 next points to 4. So 2 next, we have to uh, change its next. So and 1 next points to 2. So this is our current head. So head next is 1, and 1 next will point to 2. 1 next will point to 2. So I will write it like this: head dot next means head next is 1, and 1 next initially it is null. So it will point to head itself. So it is not null, it points to head. It points to head. And 2 next I will reinitialize to null. So head dot next is null. Head dot next is null because this is our head node and its next is null at the end. So we will get to it, and after that we removed this from our recursive stack. Now we have this 3. So head points to 3. Head next is 2, and 2 next will point to head itself, and head next will point to null. Now we are done with 3, and we are at 4. So this is our head node. Its next is 3, and 3 next will point to 4, and 4 next head next will point to null. So we have this: 1 next points to 2, 2 next points to 3, 3 next points to 4, 4 next points to null. So this is our head node. This is our reversed linked list, but we want this as our head node. So while going to your previous state, or while removing the state from our recursive stack, we will return the answer. So answer next points to null. So this is our last node. So we jump to this and we return this answer. At this stage we will return our answer points to this. So we will return our answer. We are at this stage, we will return our answer. We are at this stage, we will return our answer points to this value. So that's how we will reverse our linked list. So let's code this. First we have to reverse our linked list. So we have reverse, and this is our reverse function. This is our base case. If head is null means there is no values, or this is the last value, this is the last node. So we will return head, and after finding the next nodes, the answer points to last node. Answer points to last node. And there's two line that we have to there's two things we have to do. Head next means head next will point to head itself. That's how we will reverse the links. and head dot next will point to null, so it will not create any cycle. And at the end we will return our answer points to last node. So that's how we will return, we will reverse our linked list. After reversing the linked list, we have to add a value. The value is 1, so we will add 1. Current points to the initial node, while we have a carry, so we will take the value, current value, and the value that we want to add. So we take the mode because we want the values in between the range of 0 to 9. So we change or modified our node. Then we take further carry. So carry is value divided by 10. Then we go to next node. So remember, if current points to the last node and there's still carry present, then uh, if we go to the next node, the current points to null. We don't want this, we want current points to the last node. So if this is the last node, so we will just break out. And if there is a carry present, like in the uh, test case of 999, so in that case, if there is a carry present, so we want to add 1 after the last node, and at the end reverse, at the end we will reverse the linked list and return it. So let's submit this, and in between let's talk about the time and space complexity. So we have a reverse function. In the reverse function, this is a recursive function, so it will call again and again, so it will call n times. You can optimize this by applying iterative reversal. So then it will be, then it will take no space. Now it is taking a stack space, so you can optimize this, but I prefer this way because in this way we have to write smaller code. And next we are just iterating. So the time complexity is order of n, and the space complexity, in this case if we consider this stack space, then it is order of n, but you can improve this. The code for the iterative reversal is provided in the description box. If you want to check out, feel free to do so. And thank you all for watching this video.